Hello and welcome to 7 Blue Pixels Tutorials. Today we are looking at how to make a 3D diorama. So we have our scene set up and I have a hemisphere here with a couple of rocks from the asset library, and on top of that, if I turn off line shading, I also have a disk here, and this disk is acting as our collider for our water particles. We don't want too much going on, so we've just dropped it down a little bit, and even though it's hanging on the outside, that's not the end of the world for us for the purposes of what the disk is for. So I'm just using the traffic light system, turn it off. And also I'm just going to make sure that each of these have the collider tag on them as well, because we want the water to be reacting with them. So let's get this now. So we go Insydium, we go Xparticles, and we bring in a system. This will be the quickest and most efficient way of us getting exactly what it is that we need. You can see that our emitter is a square and it's facing out. So if we use our move tool, we can see which way this is going using the normals. So if I press play, we're going to change our emitter type to a cylinder, and we're just going to use the little dot here and bring that height in a little bit. And we're going to rotate this around using shift on the axis to get a nice even turn. And then we're just going to use this circle, this little dot here on the outside, to just bring that out a little bit. Okay. So what we need to do, we need to also make the sphere a collider. So we're going to control click that down. And now you'll see that the particles are sitting inside our sphere. We need to go into Nexus and go nxGravity. And as you can see, what this does is that it brings everything to the bottom. So we're going to go back into our Nexus system, and we're going to go into Nexus, and we're going to up here to add a nxFluids. And what this will do is it will now change how the particles are being used using a solver. So it's important that we get these settings right here for the solver. So I'm going to stick with xpCache for now. Everything else is fine here. So if we press play, give it a moment to calculate, because now it's calculating a whole new way of dealing with these dynamics. You can see that these particles are, and if we increase the range down the bottom here, we'll see it going for longer. You can see these particles are just kind of hitting that disk that we've got here and essentially almost bouncing out. So a way to fix this on the outside here is if we go to sphere and we click on the subsurface icon here and hold it, and we go to thicken and hold Alt, this will thicken our sphere. Obviously we don't want it that thick, so let's maybe just drop it down to maybe 1.5 just to give a little lip to it. And we're going to move the collider tag up to the thicken. We're going to change normals to NA just to make sure. I don't like to leave anything to chance. And we're going to watch this again. And as you can see now, they all stay inside. Now as you can see, as we have more and more particles, it's filling up and then spilling over the edge like you would get with water. And because the surface tension is quite high, etc., we're able to kind of see that. So let's change the display into something that we can see more of. So let's change it to a circle, and this will actually change it to the radius settings here, the radius settings in the basic particles tab that we've got. So they're 3 centimeters wide each particle. We need to get the particles moving how we want them to move. Okay, so we need to change this to perhaps another kind of emission type. So I'm going to change it to shot, because we only really want one frame of particles. We just want them to kind of drop and exist into frame. So if I show you what that looks like now, we press play, let it recalculate, and as you can see, they literally just dropped into frame at a count of 1,000 particles. Duration 1 frame. We don't want them to come in with any speed, so we're going to drop this to 0 centimeters. When we play again, and up in the Nexus settings up here, I'm going to add a nxWave. So we're going to go up here to nxWave, and as you can see, we get this huge looking thing here. So if I turn off the particles for now, and I'll just play this, you can see how this is working. It's kind of acting as a wave system. Okay, so let's work out how we can make this look a little bit better. I'm just going to change it to a grid, just so that we can see the bottom a little bit better in the displays. Actually, we're going to drop the strength down. We're going to drop the speed down to, I don't know, let's call it 30 centimeters for now. Maybe even less. Let's go 10. We're going to change the noise type to wavy turbulence. As you can see, this changes everything a little bit, gives it a little bit more variation, a little bit more dynamic and kind of look into what we want. You can change the time scale by 50%, and that will slow it down. So if you're going for like a slow-mo look or anything like that, or you just want a slower wave, you can manipulate the time scale, allowing you to do that. So how does this now affect the particles? So we bring our emitter back, and we go back to the start, and it will calculate everything now. It's got even a little bit more to calculate, and as you can see, these particles are moving. So if we turn the wave off using our traffic light system, you can see everything's starting to move just a little bit. So we need to add a bit more strength in. If I do something wacky like that at 52 strength, you can see it is just causing absolute chaos there. So let's drop this down to 25. And it could be that we don't have enough particles in here. So let's increase the particles. So we go into our emission. We go to 5,000. Okay, as you can see, we're starting to get some actual variation in our liquid here. So what we can do is we can go into Control D or Command D into our project settings. We can go to Xparticles, and we can just change the substeps to, I don't know, something like 3. Okay, so now we're getting things a little bit better and kind of close to how we want. Let's look at the best way to get water particles in. So we're going to change this shot type here to hexagonal. And now we change it to hexagonal, it will use the radius of our particles to determine the distribution. So if we go one more frame and just look at the distribution, we turn off our sphere and our disk. You can see the distribution is now as even as possible based on the radius of our particles and also the emitter size. So if I increase the emitter size just a little bit, and I perhaps lift it up, and we reset by going one frame and let it calculate, you can see we've got, it's almost like a honeycomb kind of look, but it's how the particles are now distributed, and already some are starting to clash with each other. So let's bring back in our rocks, and as you can see, our rocks are maybe too tall. So let's bring our rocks down. So we're going to click on our rock group, and we're going to bring that down, and we're going to put that in the center, maybe increase the scale just so we can see more of what's going on. Okay, and what we could do is we could also bring our disk up so that we have a little bit more to play with. I'm just going to make sure the outer radius of that just sticks outside the edge to stop any kind of clipping of our particles, but we can find a way to deal with that in a minute. So now that we've done that, we'll restart the simulation. And obviously that's not where we want it to be. So we're going to drop down a disk just until we can see where those particles sit nicely on the top. And we'll start again. And as you can see, everything's reacting how it should be. But we could probably get a few more in here if we drop the size. Now when it comes to hexagonals and the emission radius, or the particle radius, even if we drop it by like 0.8, it's still going to be able to add 1.8, sorry, we're still going to be able to add a huge amount of particles in there because it's done by the size and how it packs it in as most efficiently as possible. So if we did drop this to 1.5 and we go one more frame, you'll be able to see the huge amount of particles that we're getting in there now. You know, for the purposes of this, I think that's looking really good. You can see what we're getting at. Happy days. So we're going to grab the sphere and we're going to control and bring it up as a separate object. And we're just going to reverse the rotation. And we're going to leave this on top. And now what this will act as a lid. So these particles that are falling out the edge here, if we go again and we stop it, you can already see them bouncing back in, as if there's like an actual invisible wall there that's preventing them from going outside. And this gives the idea that there's more dynamics and more flow going on inside. And already that's kind of just a cooler look in general. And if you wanted to, you could add a glass material to this or anything to actually look like a lid. But it kind of looks really cool anyway, because the waves keep going. They kind of sink back into themselves and you still get a really nice look going on. I'm going to go up to Nexus. I'm going to grab an object. And I'm going to put a nxKill modifier. An nxKill modifier is quite interesting because if we, for example, we turn off our rocks for the time being, as you can see, that's the hole where the rocks are, and we change the shape to sphere, and we reduce this down to 100 centimeters. For example, if we reduce this down to 80 centimeters for the purposes of this, and we press play, the idea is that anything that is outside of the kill box or the kill sphere will just go. There'll be no particles outside of it. So this kind of acts as like a clipping base. So if we go back to the start and we increase our radius to just outside, as you can see, just outside our sphere, 1 centimeter over. Any particles that end up going just outside our lid, so if they clip through for any reason, they will now just cease to exist, which will make the simulation look a lot better in final renders because you're not going to get anything clipping outside. And we got one more thing that we could do to just really enhance our particle simulation is we could add a nxFoam. So with nxFoam, if I turn off our emitter particles for now, I'm going to go add emitter. Don't worry about necessarily how that emitter's looking right there for now. And we're just going to bring this in. And we're just going to name this foam emitter. And if we press play and let everything calculate a little bit, we're not seeing our main emitter, but what we are seeing is our foam emitter. So these are the, the whitewash particles that sit on top of waves. Now we don't want to change anything in this emitter control. We want to change it within the nxFoam. So I want after age maybe 10 frames. There we go. So we're starting to get them immediately. And perhaps I want a few more on the crest. And let's maybe add a few more on the air rate as well. And if we start again. And already we're starting to get a lot more particles, which really help the look of our waves. But we want a little bit more going on. So we're just going to add one more nx modifier, and that will be a nx vorticity. And within this vorticity, we want to be able to push things around a little bit more. So if I, for example, increase the strength to 50%, and I press play, and again, we're only looking at the foam particles here, but now we're starting to get a few more on the outside here, where we're generating a little bit more aggression in our waves, so that these foams, bubbles, particles are all starting to come up from the bottom and actually kind of generate a little bit more interest in what we're looking at. And so what you've noticed in the settings here, I have a lot more foam particles. I've reduced the minimum speed down to 50, so once the particles have reached the speed of 50, they'll appear. And then also the surface, so I've reduced the amount of percentage that needs to cover. So as you can see, we have a lot more foam, and already that makes a really interesting look. You could do this as a visual representation of something. We are going to go into our utilities, and we're going to get a xpCache, Xparticles cache. So I always like doing it to an external file. You could do it to internal memory, which will be embedded into the Cinema 4D file. But if we go external files, I mean already, look, if you just look at the white and blue there, that looks so cool. Looks so cool. And then once we found a place for it to be saved, I'm just going to hit build cache. And it will take a few minutes, and we'll come back after it has cached. Okay, so it has cached. That took about, give or take on my machine, about 5 minutes. So if we play this through now, it will just play the cache of the render, so we get a really nice quick look. We can put our rocks back on, And already you can see everything looking really quite cool. That kind of wave at the end is looking really nice. I really like the look of that. So we're going to go into generator and we're going to get a xpOpenVDBMesher. So nothing's changed so far. We turn off foam emitters for now. Nothing's changed so far. But if we bring our emitter into the mesh and we turn our emitter off, you can see how it's already turned those particles into a mesh, but this is obviously not what it is that we're looking for. So we need to look at our voxel size. So the voxel size are essentially how big the detail is going to be. So if we bring it in, we get less detail, or more detail, sorry, we bring it out, we get less detail. Depends on the look that you're going for. There's no right or wrong answer here. So how do we get this down to size? So the voxel size is obviously going to be our detail, but I'm fine with it in 4 for the purposes of this. So what do we do? So we scroll down, we see point options. So if we increase this, we get a thicker and thicker waves. So this might be good if you're doing clouds or marshmallows or kind of any of those things, really. Really good stuff. But what if we're not doing that? What if we do want water? So we can reduce this now to something that we can go a little bit below the voxel size, but ideally you kind of want it around the voxel size. So if we want it smaller, we can do this. And already we're getting something that is looking really quite interesting. If we press play still, we're kind of getting a really nice water look there. So if we drop this down to 1 even, sorry, 1. And with our voxel size, with our point radius, we can increase that again. But if we drop that down to 1, and we press play, so we're starting to see the individual particles, and it's starting to look a little bit, I don't know, mincemeaty, but we can fix that. So we're going to go into our filters, and we're going to use filter, and already the default median that's there is giving a much softer look. It's trying to blur the particles out to give it a smoother look. But we don't want the median. What we want is a curvature, because curvature works a lot better with water. So that's what the median looks like, and that's what the curvature looks like. We can still keep a lot more detail in there. Into our deformers and get a smoothing deformer, and we're just going to place that underneath the xpOpenVDBMesher, if I can get my words out. And as you'll be able to see, it's already placed it underneath, and you've already seen a massive impact here. If we turn it on and off, a huge impact here. So now in our smoothing, we can have a look at kind of what we're doing here. So you could change this to any kind of other effect that you want. But this is going to help really keep a nice look to this. As you can see, slows down the playback because it's not cached. But we're starting to get the nice looks, and now we can start replaying with voxel sizes or point radius or anything like that. So the voxel size can't go above the point radius. So we need to make sure that's right. So if we just increase it to 1.5 with a voxel of 1, already we've got a really nice water look. If you have a look at that, you can see how the foam emitter still sits on top of everything. And you can see how it's reacting with everything. It's looking really nice. There we go, look at that. So now we're happy with that. Let's work out how we're going to get our foam particles shown. Cool, so how are we going to do that? So we're going to use Redshift for this. So within our foam emitter, we're going to right click, go down to render tags and RS object. In here you'll find a particles tab, which isn't always there. For example, if I go to the sphere and I do render RS object, you'll find that the particle tab isn't there because it doesn't recognize it as a particle object. So if we go back to our foam emitter and we go to particles, and let's get our Redshift render view up. I'm just going to place it here on the side. So now it's going to show us what we're looking at. Let's turn off our lid. Okay, so obviously we're not seeing any foam particles on top, and this is kind of a problem because we're seeing it in the viewport. So how do we see that? So we're going to go down to mode. We're going to change this to sphere instances. And already you can see them all pop up, but they're far too big. So we go to the scale modifier and we're going to drop this to something really small. And already That's looking so much better. How do we now fix the water? So this now comes down to you. This all depends on your own shading, lighting, however it is that you want to do. So I'm just going to quickly do that and come back and let you know what I've done. Okay, so what we've got here is I've added a new material to the bowl. I've also added, if we go through, I've also added some nice water texture to the VDBMesher, as you can see. If I just change the view on that to maybe a constant shading, you can start seeing the outlines of it over here, for example. And I've also gone in and made a foam sphere, which I've added a custom material on, and then in the RS Object Manager I've changed it to custom objects and put the foam sphere on there. So now these are all custom spheres. So if we look at my current render that I'll show you at the end of this video, and you probably saw at the beginning, you can see that the particles just move a little bit better. They are custom spheres and they react a little bit better to the lighting. And as you can see, I've got a dome light with a HDRI with a glass texture on the bowl, which gives it that look and with like a nice earthy look. And with the rocks, you can see the water just sitting around it, which is really nice. And the texture and the lighting of the water really interacting as well. So yep, that's what we've got so far. That is essentially how you do a water-filled diorama. I've also got a new RS object camera here where I've set it into view, and I've also added a slight depth of field with a focus distance just to kind of give it a little bit of character. It's all rendering out. If I do Command Control D, ACES CG, so I'll bring that into After Effects, set it up as an ACES color workflow, which I'll do another video on at some point, and that's how we get such rich color. And yeah, that is the final product. Thank you very much for joining. Please don't forget to like and subscribe. Please leave a comment if you want to see anything else or you have any other questions, and I will see you again as and when. Thank you very much.